Hi, my name is Thad Walker, and I want to show off and show my creations. I made another video, but want to try to correct some things I said and bring out full cast and crew. I did mention that this is modular origami. And these are the modules. See if I can take one apart for you. You can probably find someone else is going to do a tutorial on these. Anyway, you can make cubes out of them, and as I mentioned, they're very stable. What I did is I kind of opened up one of the four sides, stuck them together, found that was kind of cool, and I made something like a tetrahedron. I thought that was kind of cool too. I don't know if you watched my other video, but I did mention something about tetrahedrons and maybe something about their imaginary nature. You can kind of see there's a line between these 2 points and sort of see that inside. I'm talking about inside of each of these cubes. If you take off 4 pieces, there's one piece of this cube, there's another piece, and there's another piece, and then opened up and added on the other. There's maybe 8 corners, but you can take 4 off, dig a little deeper, and what you're left with is a tetrahedron in the center. So that's what I was talking about with that. You can kind of see this is a tetrahedron, but inside these 4 points is a tetrahedron. And that's what I'm describing, stacking some imaginary tetrahedrons in this. Did find a better version for some purposes that I made. I made a ring all by itself, and if it was a mathematical shape, this 7-sided piece here was of interest to me because if it didn't rely on coming together to form the shape, it actually automatically went to that shape just mathematically. Just every time you put on 1/7 of this, it would be a 1/7 of the way around the circle. I think that that would have been something unique, which made me think that this was not a mathematical shape, because I remember something about not being able to inscribe a septagon or something like that. I'm not sure what that means or implies, but that was a concern of mine. Here's an example where you can see why I cheated and glued the inside pieces. It kind of falls apart. I believe this was one time formed into a loose ring like this. But That's why I use glue. It doesn't work as well for this complicated shape as it does something like this. This requires no glue. So this and a cube, that would be really easy to do. But anyway, I cheated. I admit it. I put some glue on here. So did come up with this. So that's the module origami aspects of this. I also mentioned in a previous video that somehow this had more points of radial symmetry. I'm not sure that's exactly true. I think this has a point of radial symmetry to match the number there. And in the previous video I tried to talk about some more imaginary rings besides these here, these three rings, and I didn't do a very good job tracing, so I'd like another attempt. So we go there, 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 there. Probably made our way back already. You can see that that is kind of a ring, and there would be, for each of these upper, or I guess now upper, ones of these touching sections, there would be one ring that passes through each of these, and two that pass through the lower, two of these imaginary rings, and two for this, and one, pardon, I say two, I mean three. Another thing I might have said wrong, I believe that as far as the number of tilings are concerned, spiral version and its chiral make two. And as I mentioned, if you take the top and twist it independently, you get some more. I believe I said 7 total, but these 7 more. I think that's unique for each one of them. That makes 9 tilings. So correction on that, I think a lot of people would just post over the same video. Maybe I will. This is the first video, first shot. I just want to kind of get it out there. Full of errors. Not sure if I have a proof to say that this 6 tile tiling is somehow unique in the fashion that a cube projected onto a sphere is a unique tiling from a dodecahedron projected onto a sphere. But I think it is. I'm not going to offer proof. I'll leave that to someone else. I'm sure that's a complicated thing that would take a page of writing. But I'm going to implant the idea that I think it is a unique tiling, that you can't just MC-Escher your way into adding, subtracting from an existing tiling to get this any more than you can add and subtract from the projection of a cube onto a sphere to arrive at the projection of dodecahedron onto a sphere. And then joining 2 of those tiles together. Sets of tiles in the dodecahedron. So I think I have a unique tiling here that is not just derived by the addition and subtraction? And if so, I have an infinite series of 6 tiles. So I did do some work. I did go to. If you're going to blame me for not bringing this out sooner, then you can also blame some math professors at University in Kirksville, Truman State University. I did show it off there quite some time ago. Asked for some help, and then I've been a math student, slightly familiar with proofs, so I did go off and do some calculations on my own. I was finally able to pin down and grasp what I was looking at here. As I mentioned, I don't think that the geometric shape implied by saying that these sections are like squares and they define stacked packed tetrahedrons in a ring. I don't think what's implied here by this shape is mathematically doable. I think it's slightly stretched, as I said, but it's really cool. Feel free to check my work on that. I'm not 100% certain. It was imprecise enough that I was wondering if it was like tau, but I didn't bother checking further somehow. I don't remember the details, but I did do some work. I think the tiling's real. These were fun to make. Not terribly useful. These pyramids kind of think of the triangles at their base that I mentioned inside of the ring is mathematically doable. That's done all the time. Where you have a ring of triangles like that. So the triangle faces defined by these inner pyramids would be normal to a line that would intersect in the center for all of these. The tiling I found on the face would imply something to me, but I can't make a connection there, and I just don't think somewhere in between those two things on the inside and the outside, I still don't think this is a mathematical thing, mathematically defined object that that comes together and matches up. So. Regarding the six-sided tile series, um, the series would be odd number units. A square would have three repeating units of zigzag at 120 degrees, and it has 6 tiles. And don't have dodecahedron here. I do have an icosahedron made out of these. I guess I could bring, but if you don't know what it is, that photo won't help you out. But that would have, where this has 7, this has 3, that would have 5. So we're adding 2 each time. Now, as far as 6-sided tilings are concerned, it would start with a square. I wouldn't say that you would want to limit yourself to 6-sided tilings. If you were to go down to 1 repeating section, you might have a 3-tile thing that I'm fairly familiar with. Not sure how I would describe that. It's kind of hard to repeat a zigzag one time, and maybe in some other dimension, if you were to do that, it is 6 tiles. I don't know how to figure that. So maybe there's some extended mathematics you can go in that direction, but starting out with the cube anyway, I'm going to claim knowing about that one. And then going up through, as these zigzags get smaller and smaller, up into infinity, you're going to have something like orange peels. Coming back and approaching known tilings, but there's the same countable number that you're on, plus 2 unique orientations for these, and the positioning is going to be unique in some way that I don't think is approachable by the method of addition and subtraction that you see from the works of M.C. Escher. And that's about all I want to say about that. Hopefully I got some things corrected, and I don't know. But enjoy. I guess a little bit more footage if you're really interested in something never hurt anyone. Take care. Use it wisely.